Hey, this is Dr. Gundry here. I'm going to be on live for ADAPT for the next, half hour or so. So, a lot of you who are fans of ADAPT bars know that I'm also a fan of ADAPT bars, and I've been promoting them for whoever will listen for a long time. So, I want to tell you about why I like ADAPT bars, but more importantly, why they fit into what I'm asking people to do. A number of you I know have the plant paradox, and the plant paradox, thank you for buying it and reading it. It's been on the New York Times bestseller list for 5 weeks, and quite frankly, it's gotten good reviews. So let me tell you a little bit about how the plant paradox came about. Many of you know my first book, Dr. Gundry's Diet Evolution, which was also a bestseller. But that was actually 9 years ago, and after that book came out, a large number of people with autoimmune diseases began showing up in my office, and a large number of people with end-stage cancer, stage 3 or stage 4, came to my office. And a lot of people with memory loss, dementia, Parkinson's, Alzheimer's, either came to see me or were brought to see me. And we've been lucky enough through the years to find a lot of laboratories around the country that can do some very sophisticated tests that thankfully insurance and Medicare usually covers most of. And my patients have been nice enough to me that every 3 months or 6 months we would get 10 to 12 vials of blood and see what the results of making dietary interventions were, and asking people to take a bunch of supplements. And many of these supplements come from Costco or Trader Joe's. As you know, I became so popular with my supplement ideas that I founded Gundry MD, where you can now get my supplements, but that's another story. So when we started looking at all the blood work of everybody, some very important findings came about. And I like to report these findings at national meetings like the American Heart Association, the European Atherosclerosis Society. For instance, 2 weeks ago I was in Vienna giving a paper at the 11th World Congress of Targeting Polyphenols. And if you've listened to me in the past, you know I'm a huge fan of polyphenols in general. So when we started looking at people's blood work, a lot of things became fairly clear, at least to me. And one of the things we started following is called insulin-like growth factor, sometimes spelled IGF-1. And if you've read The Plant Paradox, you know that I've become more and more obsessed with insulin-like growth factor, as it's a very good marker for, if nothing else, how fast you're aging. And my studies and other studies of super old people show that one of the things they tend to share is a remarkably low insulin-like growth factor. And you can prove this in animal models. And so where does insulin-like growth factor come from? It turns out that there's really two big drivers of insulin-like growth factor. And one of those is the amount of sugar you eat. And sorry about that. Sugar in all forms is, quite frankly, bad for you. And the second thing that it comes from is animal protein. And sadly, even a fish or a shellfish is an animal. Now, I grew up in Omaha, Nebraska, and Milwaukee, Wisconsin, where, quite frankly, animal protein is king. And it is unfortunate that animal protein is, quote, bad for you. But it turns out that really good research at USC and Walter Longo's lab, at St. Louis University, has looked at the influence of animal protein on insulin-like growth factor. And I won't bore you too much, but some of the work that has been done at St. Louis University is actually particularly interesting. They've had the pleasure of following a large number of people who are members of the Calorie Restriction Society. And these folks, in general, limit their calories to about 30% less than would be normal. And as you imagine, these folks are very thin, very skinny. The interesting thing about these folks is that they have remarkably normal insulin-like growth factors. And that is somewhat surprising because calorie restriction in at least animal models extends lifespan, except for the animal model rhesus monkeys. And I talk a lot about this in the plant paradox, but there were two competing groups in the rhesus monkey trials for longevity and calorie restriction. One from the Institutes for Aging in Washington, D.C., and the other from the University of Wisconsin. And they had actually different findings. The group from Wisconsin showed that their calorie-restricted monkeys actually lived longer and better than their non-calorie-restricted monkeys, whereas the group in Washington, D.C. did not find that. Now, when the University of Wisconsin looked at the difference in the food that the two groups were eating, it turns out that the University of Wisconsin group was actually much more protein restricted than the Washington, D.C. group. And I used this as a clue that perhaps they were onto something. So the University of St. Louis folks did the exact same thing. They looked at their vegan population, and the vegans had remarkably low insulin-like growth factors. So then they asked their calorie restriction folks to go vegan. And interestingly enough, the calorie restriction folks that they recruited who followed a vegan diet dropped their insulin-like growth factors. So sadly, this has been put to the test in humans, and if you want to lower your insulin-like growth factor, then I suggest that less animal protein is better. Now, a lot of us aren't going to do that. Quite frankly, I take care of a lot of vegans and a lot of vegetarians because of my association with Loma Linda University, which is an Adventist healthcare system, which is a vegetarian religion. And some of my vegans, when I meet them first, are some of the sickest people that I've run into. And it has to do with the plants that they think are healthy for them that are actually trying to kill them. And that's one of the paradox of the plant paradox, that you have to know which plants like you or which plants you've become accustomed to, and which plants that really don't want you to eat them, or correspondingly their babies. And I think that's a good segue into talking about the plant paradox in itself. Plants were here first. They had it really good before animals arrived. Nobody wanted to eat them or their babies. Now, plants are subject to evolutionary pressure exactly like animals. and that is whatever they can come up with that makes them survive, or more importantly, their next generation survive, in general will be selected out as a winning combination. So when animals arrived, plants had a problem, and because they didn't need to run, they didn't need to hide, and they didn't need to fight with other plants. But now they had to defend themselves, and their only defense mechanism is chemical warfare. And plants are great chemists, so they use chemical warfare, to make animals ill, not thrive, or think twice about eating a particular plant or plant baby. The idea is that an animal that's not doing well eating a particular plant or a seed says, you know, this isn't worth it, I'm going to go somewhere else and eat something else. The plant wins, the animal wins, and everybody's happy. Humans, unfortunately, as most of us know, are pretty stupid. And so when we eat things that make us feel lousy, or our stomach hurts, or our head hurts, or our joints hurt, or we get heart disease, we keep eating these things, and then I get to do bypass on you or do stents, and we just never learn. Now, what I've found is that it's quite possible to teach people to learn which plants to avoid and which plants not to avoid. And a lot of it has to do with our evolutionary history. So we evolved as tree-dwelling animals. We actually came from tree shrews. And I like to joke that if your significant other or spouse calls you a rat, take it as a compliment, because that's actually where we came from. But we spent 40 million years eating the leaves of trees. Unlike antelopes and cows and horses, we did not evolve eating grasses, and they're totally different in their lectin content. And for those of you who don't know what lectins are one of the plant proteins that's designed by the plant to make us ill. And lectins actually act like incoming guided missile attacks on us, on the inside of our gut, on our joints, on our brain, on the inside of our blood vessels. They're really good at what they were designed to do. So back to us, we were designed to interact with the lectins in two-leaf plants, dicotyledons. We weren't designed to interact with one-leaf plants, the grasses, monocotyledons. So our immune system are used to these sorts of lectins. But more importantly, the bacteria that live in us and on us, our microbiome, have also evolved to handle those lectins and to also tell our immune system not to be too worried about these particular plants. They basically text message our immune system and say, hey, we know these guys, we've known them for millions of years. Yeah, they're a pain in the neck, but don't have to get too bothered by them. We've got this handled. Now, fast forward to 10,000 years ago, when we began eating the lectins in grasses, grains, and the lectins in beans. Now, beans are so inedible that 5 raw kidney beans or 5 raw black beans will kill a human being within 5 minutes by coagulating your blood. So needless to say, we would find out very quickly that that's probably a bad idea, or we wouldn't be around to tell anybody it was a bad idea. But cooking absolutely diminishes the amount of lectins in beans, and we've been naive to think that cooking gets rid of most of the lectins in beans, which it does not. Most lectins are heat resistant, and as those of you who've read The Plant Paradox know, the only way to actually destroy a lectin is a pressure cooker. And If we have time, we'll talk about that a little bit later. So, humans were actually very tall creatures 10,000 years ago. We stood about 6 feet tall. Our brain size was 15% bigger than it is today. And by 2,000 years into agriculture, 8,000 years ago, we had actually shrunk to about 4 foot 10 inches. We lost over a foot in height, and our brains shrunk dramatically. So the idea that we were small creatures and now we're getting big is actually not true. We were actually very tall, and we shrunk thanks to the lectins in grains and beans. Now, from a plant standpoint, that's a really, really good thing. Think about it. If you're smaller, you're going to eat less. And one of the things I like to point out is that Asians, for up until the last generation, who were mostly plant predators, rice and pulses, were remarkably short. And it's only been in the last generation, when the Western diet has penetrated Asia, that we've seen Asians shoot up like weeds. And it wasn't that they were getting better nutrition. In fact, they had great nutrition before, but they were getting less of the plant lectins that were keeping them small. Now, as I talked about in my first book, Dr. Gundry's Diet Evolution, smallness is not a bad thing. In fact, you have found in research that tallness is actually not very good if you wanted to live a long time. And in general, tall people have shorter lives than smaller people. And it's the same way that your miniature poodle actually lives twice as long as a standard poodle. So the next time we think that height is a great idea, or that our children should grow rapidly, we've got to think again, because we know that children who grow rapidly have actually much higher incidence of cancer than children who grow slowly. And that's not a good thing. So the second thing that happened in the time scale happened about 500 years ago. And this is actually, I think, one of my favorite subjects on lectins. All of us in North America are not from North America. We're from Europe, Asia, or Africa. And that means that none of us ever encountered a plant or its lectins from an American plant until 500 years ago, when Columbus started Columbian trade. And American plants went to Europe, and they went to Asia and Africa. So that 500 years to get to know a new lectin is speed dating in evolution, and I don't think it can be done. Now, the problem is some of our favorite foods are American plants, and some of these are just plain old dangerous. The nightshade family. There's a nightshade sitting on the plant paradox. It's a smashed tomato, and it's smashed on purpose. The nightshades are all American: potatoes, tomatoes, eggplant, peppers, goji berries. Goji berries are from America. They're not from China originally. And these have compounds that are absolutely a really good cause of arthritis and pain. Traditional cultures, like the Italians, who obviously love their tomatoes, the Italians refused to eat tomatoes for 200 years after Columbus brought them back, because they knew how dangerous they were. And to this day, Italians always peel and de-seed their tomatoes before they make tomato sauce. Go to any grocery store, buy a glass jar of Italian bell peppers, red peppers, and you'll notice that the peels and seeds are gone, because that's where the lectins are. And Italians have been doing this for hundreds of years. Still don't believe me. The Southwest American Indians, Native Americans who are actually from Asia, always peel and de-seed their peppers before they use them or grind them into chili powder. In a few months, the Hatch Chili Pepper Roast in New Mexico will happen. I urge you to go and watch how they roast their chilies and peel the peel off and then de-seed them. Still don't believe me? Go to your grocery store, buy a can of chopped green chilies, open it up. There won't be any peels and seeds because they're gone. So traditional cultures have been smart enough to get rid of the lectins in the nightshades. Other problems with American plants. Peanuts are a bean from America. Cashews are a bean from America. Cashews are a member of the poison ivy family. So the next time you're munching on cashews, go out in the woods and start munching on poison ivy if you think that's a great idea. The dermatologic literature is full, as I point out in the plant paradox, of examples of cashew toxicity, particularly to mucous membranes in hands. Believe it or not, cashew pickers actually have terrible burns on their hands, so stay away from cashews. The American seeds, pumpkin seeds, sunflower seeds, chia seeds. The famous professor at Colorado State, Lauren Cordain, advised me a number of years ago that chia seeds produce inflammation in humans and was kind enough to send me a couple of papers about it. And in fact, they do. And I have a number of my patients with severe autoimmune diseases where they can tell from 50 feet whether they're eating chia seeds. And I just had one in the office this past week. So chia seeds are not a health food. Stay away from them. Okay, so the third thing that happened in modern history was 2,000 years ago. Northern European cows suffered a genetic mutation. They started to make a protein that's a lectin-like compound in their milk called casein A1. Now, the normal protein is called casein A2. It's present in southern European cows, it's present in goats, it's present in sheep, and it's present in water buffalo. Now, the problem with casein A1 cows, like the Holsteins, are that they're hardier and they give more milk. So that almost all cows in the world are unfortunately the wrong breed of cow. And there's a movement to restore herds of cows to casein A2 cows. And if you're lucky enough to live in California and Florida, you're starting to see A2 milk beginning to be in grocery stores. So A2 milk is the, if you will, the original milk. And I'm convinced, as are others, that most people who think that they're lactose intolerant or that milk gives them mucus or that milk gives them stomach issues, it's actually casein A1 that's in the milk that's the problem. And just in the last few weeks, I've had several of my patients come back from trips to Italy who were, quote, lactose intolerant, and they were amazed that there was no lactose in Italian gelato because they were able to eat the gelato just fine, and that proved that there was no lactose in gelato. Well, in fact, there's plenty of lactose in Italian gelato. What there isn't any is there isn't any casein A1. And so they could tolerate that gelato because it was the right casein and they weren't reacting to casein A1. And interestingly, a couple of my patients came back and tried American gelato and immediately reacted to it. So there's plenty of lactose in Italian gelato. There just isn't any casein A1, and that's why people could have it. So I think this is a real thing. There's a new study out of China that suggests that casein A1 milk is a major cause of type 1 diabetes, which I wrote about in the Plant Paradox. And so in general, stay away from casein A1 milk products. So how do you do that? French and Italian butter is perfectly fine. Goat butter is fine. Goat yogurt, sheep yogurt, coconut yogurt. Any sheep or goat cheese is usually safe. And most cheeses from France, Italy, and Switzerland are from the right breed of cow. Buffalo mozzarella from Italy is perfectly safe. We're beginning to see buffalo mozzarella come out of a farm in Uruguay in South America, which should be perfectly safe. They're pastured, so be on the lookout. Now, a word of advice to all of my ApoE4 followers. Many of you have gotten to know me because of my taking care of large amounts of people who carry the ApoE4 gene, which is unfortunately called the Alzheimer's gene. It's called the Alzheimer's gene because it's the only known gene that associates with increasing your risk of Alzheimer's disease. Let me make it perfectly clear, it does not cause Alzheimer's disease, but it certainly increases the risk. And in general, animal fats are not very good for ApoE4s, and cheeses are one of those. So if you're one of the ApoE4s who are watching, in general, you want to lessen the amount of cheeses that you're eating. There's certainly some actually quite good plant-based cheeses out there. I have no relationship with them, but Kite Hill makes some very interesting cheeses out of almonds, and they're actually a great substitute, particularly for my ApoE4 folks or for my vegans, and I recommend them. So a lot of options in that respect. So as a summary of the plant paradox, the longer you've been associated with eating a particular plant or its babies, the better you are to handle those lectins, the more evolved your immune system has been to recognize and not react to those lectins. But most importantly, the longer the bugs that live in your gut, your microbiome, or what I call the holobiome, have developed defense systems against lectins. Now, why all of a sudden are things that we seem to have no problem with for thousands of years kind of rearing their ugly heads? And that's the second part of the plant paradox that I think is equally as important. And those of you who have read the book, it's the 7 deadly disruptors that have really screwed things up in our detent between plants and animals. And number one on the list is broad-spectrum antibiotics. Broad-spectrum antibiotics were invented about 40 years ago, and they were miraculous because we doctors didn't have to actually know which bacteria that we were treating, and so we could just shotgun someone who came in with what we thought might be a bacterial infection with a broad spectrum antibiotic and not have to wait for a blood culture or a culture of the throat. We could just shotgun approach, kill everything. Now that seemed to be great, and quite frankly, broad spectrum antibiotics are life-saving when we need them. But what happened was we could give this stuff away like candy, so that if anybody came in with a cough or a sore throat, rather than assuring you that more than likely this was a virus that was going to go away in a couple of weeks, whether or not we gave you antibiotics or not, we could hand out cheap antibiotics, and you'd feel like you were doing something, I'd feel like I was doing something. But what we didn't know is that we were actually not only killing whatever bug we thought we were killing, but we were wiping out our entire microbiome in our intestinal tract. Now, our microbiome is actually, if anything, far more important than all the cells that make you human. We have about 5 pounds of bugs that live inside of us. And within those bugs actually are 90% of all the cells by body count that make up you. You're basically a condominium for bacteria. So you're their home. And if you want to get really deep dive, about 99% of all the genes, all the genetic material in you, right now as we're speaking, are actually non-human genes. They're viruses, they're bacteria, they're fungi, they're molds, they're worms. 99% of you is not you. They have an incredible interest in you because you're their home, care of their home. And the more we take care of them, the more they take care of us. So imagine that these guys are living in your gut, and all of a sudden you pour napalm on this tropical rainforest that lives in your gut and burn your rainforest down to the ground. And that's what happens every time we take broad-spectrum antibiotics. We just carpet bomb our tropical rainforest. Now, it sounds like, okay, well, we can just grow that back real quick. I'll take a handful of probiotics, friendly bacteria, and everything will be fine. Really? That's like we have a forest fire here in California, and I go out tomorrow and I plant all sorts of little pine trees and oak trees. How many years do you think it's going to take to grow a forest back? 20, 30, 50? A mature forest takes actually 100 years. And we're beginning to realize that the same thing happens in our gut. In fact, there's some very interesting papers that a single dose of broad-spectrum antibiotics may completely wipe out your gut flora for up to 2 years. And maybe only a single species instead of 10,000 will actually grow back. Here's the other bad news. We hear about antibiotic resistance or, killer bacteria. It turns out that broad-spectrum antibiotics kill off kind of the good guys first, and a few of the bad guys are able to kind of hang on. And it turns out that the good guys actually do a whole lot of great things for our immune system. They actually text message our immune system about how things are going in the outside world. Everything you swallow, believe it or not, remains outside of you. It's a tunnel through you. And those bacteria tell our immune system, hey, everything's good down here, we're feeling great, we're down here on the beach having a campfire or singing Kumbaya, and you guys can go have a donut and relax, everything's cool. Our immune system, our border patrol or our police or our army basically says, oh yeah, we can stand down, this is great, everything's fine. Now imagine what happens if we wipe those guys out with some antibiotics, and all of a sudden we've got gang members who are moving into our quiet little neighborhood. Now all of a sudden you're putting bars on all the windows, and you've got neighborhood watch patrols, and you got somebody in the neighborhood watch patrols shooting guys with hoodies because they look a little bit different. That's actually one of the big reasons why we have so much autoimmune disease, because our immune system, our neighborhood watch patrol, if you will, is now so worried that things are so out of sorts in our gut that they're willing to shoot at anything that looks suspicious. And that's why we have this epidemic of autoimmune diseases, among other things. And one of the things I do in my clinic is I get good bugs back in your gut, and we re-educate the immune system by taking away lectins that everything's okay and we don't have to shoot at anything that moves. Now, the second thing that happened is that we used broad-spectrum antibiotics to grow animals quicker and faster. It turns out that manipulating the gut flora in a cow or a pig or a chicken with some antibiotics will make that chicken or cow or pig fatter and fatter and grow faster and faster. And isn't it interesting that that's exactly how we as humans grow faster and fatter? Is because we're dosing ourselves with antibiotics, but also those antibiotic residues are in the pigs and the cows and the chickens we eat. And don't be naive enough to think that just because the FDA has said that this shouldn't be done in animals, the FDA gives a loophole that any veterinarian who believes that his flock of chickens are threatened can still dose them with antibiotics. Because you're not going to take one chicken and say, oh, that one looks sick, I better take him aside. No, you're just going to dose the entire flock with antibiotics. And just recently you probably saw in the news that a major natural chicken producer was heavily fined by the U.S. government because, lo and behold, there were antibiotic residues in their natural chickens. And there were all sorts of other fun stuff as well, including antidepressants. Believe it or not, you want your chickens to be happy while they're being crowded into all their cages. And gosh, you ought to give them antidepressants. So think about that the next time you're having a free-range chicken. Because the federal government allows these companies to cram chickens in a warehouse, beak to beak, never let them outside, but open a door for 5 minutes every 24 hours, and the chicken has the potential to go outside, which he won't. And that, by definition from the federal government, is a free-range chicken. So please don't eat free-range chicken. If you're going to eat chicken, eat pastured chicken. That means the chicken went out and ate bugs, and get to know a farmer who does that. Okay, so antibiotics, big problem. Number two, second big problem, non-steroidal anti-inflammatories, the so-called NSAIDs. You know them as ibuprofen or naproxen, brand names like Advil and Aleve. It turns out these guys blow giant gaping holes in the wall of your intestines. And the drug companies have known about this since their inception. It turns out, I did a podcast with Dr. McCullough last week. I don't think it's aired yet, but stay tuned. But Joseph McCullough was a pharmaceutical intern during his days in medical school. And he remembers the days when these drugs, Motrin was the original, and naproxen, were prescription only, and there was a black box warning that they could only be taken for 2 weeks maximum because they were so dangerous to the walls of our intestines. And now we take them like candy. There's even children's Advil, for goodness sakes. And these things absolutely are like swallowing hand grenades. And not only do lectins get through the wall of your gut, but these little bacterial particles that are called LPSs, and I don't swear, but in the book I call them little pieces of, and I don't know if I'll be bleeped, but we're live so they can't. And these guys actually create more inflammation. And the drug companies know this, so that the more of these painkillers you take, believe it or not, the more pain you will develop, and you will graduate to the next level of pain medications, which are the opioids. And imagine that opioids are the largest selling drugs in the world, and everyone knows what's happened with that. So please, please, please stay away from these painkillers. They're incredibly dangerous. In the same light, we use PPIs, proton pump inhibitors, like candy. So this is Nexium, this is Prilosec, this is Protonix. These were prescription medications with warnings that they should never be taken longer than 2 weeks because of the dangers they cause. Now, of course, they're over the counter. And, Larry the cable guy tells you to take Prilosec OTC so you can have a corn dog, so you don't get heartburn. Well, believe it or not, Larry, the heartburn is coming from the lectins in the corn that you're eating. And it'd be a lot easier not to eat the corn dog than to swallow a proton pump inhibitor, which not only changes the bacteria in your gut, it prevents you from having acid in your stomach, and acid actually digests a number of the lectins that you swallow. Studies of people with proton pump inhibitors actually showed that they have a 6-time increased risk of pneumonia compared to people who don't take them. The federal government says that nobody should take these over 2 weeks at a time. There's a black box warning. And you're probably aware that a recent study showed that your risk of dementia is 44% higher if you take these proton pump inhibitors. And we give this away like candy. So, those are some of the biggies from the plant paradox, the 7 deadly disruptors. It's just a start. But things have changed for you and me in the last 40 years. Our animals have been fed corn and soybeans and wheat, which they were never designed to eat. They've been fed antibiotics, which they were never designed to eat. So the rules are, it's not so much what I tell you to eat that's important. It's actually what I tell you not to eat that's going to make a difference in your life. The second thing to remember is you are what you eat, but you are what the thing you're eating ate. And find out what the thing you're eating ate, and make sure you don't eat it if it didn't eat what it was supposed to eat. Third thought to go away with, and this goes right to Adapt bars. Fruit is candy. It has been bred for sugar content. And please, please, please give fruit the boot. And Adapt bars are fantastic. I'm not a consultant to Adapt, but I think they have a fantastic product. For those of you who follow my ketogenic plant paradox, as you know, they're the only approved fat bomb that I allow. For those of you who are trying to maintain ketosis or get into ketosis, I think they're one of the better ways to do it that's on the market out there. So, cheers to you guys at Adapt Bars, and thanks everybody for watching, and check out the Plant Paradox, and hope to talk to you again real soon. Bye-bye for now.